Hello everyone. We go for the new lesson now. The new topic today is logarithms. Okay. What is this meaning and when we can use these logarithms? In general, this one will related to the exponents or index. Absolutely, they will have the relationship between these two also. So when we're gonna use logarithm, that means, for example, if I have one some number like a 60 equal to maybe 10 power x, right? I want to solve for x. In this one, it's really hard, correct? Because they choose the lowest term and we don't know. We couldn't have any way to expand it. When you make this situation to the end already, to the simplest term of the exponent or index, then the next step have to think about logarithms to help to find the value of x. Okay, so then before we're gonna do this one, come back to see what the uh, logarithms and just see the relationship between exponent and logarithms. So you see this one, for any positive number a except 1, y equal to a power x, if and only if, right? Log y base a equal to x. Now this one is a, right now a is a base. This one a is a base. Okay, it's a base. And this is the in term of in term of the pattern of logarithms. And this one is the exponent or index, right? A is base, correct? Right now a is a base. And x is the index or exponent. Okay, so this relationship between this one, just only change the base. When you want to convert from exponent or index to logarithms, you just change the base from exponent to be the base of logarithms. So you can see this, for example, this one, right? You take a look at this one. This is the exponent pattern, right? This one. Then you want to convert to logarithms. This is the base. So base move to be the base of logarithm, that's all. Okay. And then the index takes place of x. Okay, then x takes place of a here. The index x takes place of a. Okay, so now after this one, can see this number, like this one I just referred at the beginning. If I want to find the value of x of this in this case, how can I do? Because it's kind of lower term already can go on. So then we do logarithms. So then use this definition, okay, the relationship here. So this one is the exponent form, correct? Exponent. Now I want to change to logarithms. So this one, I take log 60. This is the base of exponent, correct? 10. You move to be base of the log here. And then x takes place of 10. X takes place of number 10. So x gonna be here. Okay, that's the way how to move from exponent to the logarithm form. Okay. Now we're gonna practice this one more later. But now I come back to this one first. So this one, I want to give you the definition of logarithm also. If they have the restriction log y base a, okay. This for logarithm, this one they have, if this one can find it out or find the value of logarithms, they have the condition is as long as y must greater than 0 and a here must greater than 0 and a shouldn't be 1. Okay, so this is really important. This is the restriction of the logarithms. So have to be keep in mind about this one. Okay, so that's why they say for any positive number a here, the base, except 1. So if for example I have log y can be any real number also, but okay, can be any real number, but y have to greater than 0, right? So if I say I let y equal to 2, for example, and a become 1, if in this case it's undecided, no solution. Undefined, no solution. Okay, because they did not go according the definition of logarithms, because the base a here have greater than 0 and couldn't be 1. So if you find out this one is wrong right away or say undefined, you cannot get any answer. Okay. Okay. So what else? Again, y have to greater than 0. Y have to be greater than 0. So for example, I give you again, say if y become any number, say if y greater than 0, if I say y equal to -3, for example, and base can be any number y greater than 0. So in this case, again, is divided or undivided. Can we get the answer for this? Undivided also. We couldn't get any solution for this one. Why? Because you see, because of this one, the value of y here, -3, it not go according the condition. Y must greater than 0, but this one become negative. Even though a is greater than 0, but this one still undivided. Okay. Any more according if, for example, another one, log, if I give what number, log 6, okay, and base maybe -5 like this, okay, can we find out value of these logarithms? Can we? No, same thing, undivided, okay, so this one no solution, same thing, okay, this one undivided. Why? Because see this a, right, the position a must greater than 0, but now become negative here, so it's no answer or undivided. Okay, so this really important definition. Now come to see this one, the one that give this one log 6 base 10 equal to x, then you can find the value of x, right? How you get the answer for this? Then you go back to use the calculator, that's all. Okay, in your calculator, can you go to the key, right? In your calculator here, there will have like a many key here, and there's a number, correct? So there will have some section like down say log. So you paste in the key. Okay, so you paste the word log and 60. They will show you the number right away. Okay, so if I have here log 60 base 10, right? Approximate 1.7782, something like this. Okay, so most of calculator, they will have the base 10. You don't need to change the base. But some calculator, if some student may ask, say, if I have log 60, for example, base 6 like this, how to do? Then we're gonna learn how to change the base later, right, by manual. But in your calculator can key in right away, because the new calculator, the one most of you have, when you paste 60, they will show like something like this, right? So you just enter 60 there, enter 6 there, and they will tell you the number right away. But in general, base 10, this is a common log. Every calculator have. You just key in log 60, and then they will show right away. Okay. Then you will learn how to use calculator. You can try it, okay? By yourself, you have calculator with you at home. Now we go next one. Try some more example, okay? See this, the first one, convert the following to the logarithmic form, okay? Question A, 2 power 5 equal to 32. So we use the definition, the definition here. We just talk. Then this one is the exponent form, right? We have to convert to logarithmic form. So you see, which one's the base? 2 is a base, correct? So in this one, I just like log 32, okay? And then this is the base of exponent. So base 2, right? You write it down to become base of the log. And then number 5, take place on number 2 in this side. So this is equal to 5. Okay, so this convert to logarithms pattern. Okay, now go on. This one. Question B. So B, what can we have? Now the same thing, right? Which one is the base? 2, right? 2 is the base. So you like log 1 over 2. Then base of index or exponent is a 2, right? So change to be base of the log. So you like 2 here. Then negative 1 take place on number 2. So this one become negative 1. Okay. Now question C. Same thing. Which one's a base? This is the exponent form. 10 is a base, right? So you like log 100. Move the base 10 here, become base of the log here, equal to 2. Okay, that's all. Okay, when you write down this one, you can disalign, right? You can write log, for example, like this, 1 over 2 base 2. Okay, make sure, because some students like really fast become the same thing, like 1 2 and 2 something, cannot see really clear. Base have to be subscript hang a little bit lower than the y position. Okay, now we go next one. Question, the more example, convert the following to index. Right now, convert this is a logarithm, convert to index. Okay, just do opposite, that's all. Okay, how to do? The base of the log is a 2, correct? So you move to be base of index. So then 2, right? 2 you move to here. Take 2 down here and 2 push 3 up, become on the top and then equal to 8. That's all. Question B, same thing, base is the 2, right, of the logarithms. So then 2, base 2 here, move to the other side. So 2 here, and then, right, 2 move to this side, and then 1 or 2, put it up, become power 1 or 2 equal to square root 2. That's all. This is the way how to convert logarithm to exponent. Try one more. If I have, for example, 2 equal to, say, log 36 base 6, right? Same thing, base 6 of the logarithm, move to this side. So become 6 right here, and 2 become index. So become 6 power 2 equal to 36. And then when you move the logarithm, the word gone. Okay, but when exponent, when you convert to logarithm, the logarithm word have to be there. Okay, that's the way how to convert. Now see next example. Okay, then don't forget this definition. I always have to, everyone must keep in mind, okay, the definition of logarithms. Which one? Y have to be greater than 0 and A have to be greater than 0 and not equal to 1. Now see the example. Solve the following equations. Log x base 3 equal to 2. That means you solve for the value of x. Solve the value of x. So then this one, same thing, right? How to get x? This is a base 3, right? Base 3 of the logarithm. Then move to this side. So 3 gonna be there. So this one gonna be 3 and put 2 up become index. When you move log base 3 out already, right? So this one, the whole thing move to this side, then this side left only x. So then x equal to 9. That's the answer. Okay, now next one. Question B. So here, right? Move to this side. Okay. So then become 102 and x move, put it up, the whole thing with power x. And this the whole thing move already, right? So this side left 16. So this one you use the exponent. How to do? 16 is means 2 power 4, right? And this side you move it up, use a property of exponent, move 2 up, become -1, the whole thing power x. So then we have same base 2, then we have -1 or negative x equal to 4. Then x equal to -4. So that's the answer. Now, next one. Question C. Okay, question C. Solve for x also. Do the same way. See where the base. Base is really important when you do logarithm and exponent. The same thing. You remember when we solve the exponent question, when they let you do extra question, we always observe the base. Should be the same base, same source, the base. Then you just can plus minus or can get a common factor. Okay, now this is the same idea. Base x. Now move to the other side. So x become here now. To move up become index, right? When you move this one, the whole thing, already move the whole thing. So left hand side gone. So you left 4x minus 3. Then you just solve the equation. Simplify, move it this side. Minus 4x plus 3 equal to 0, right? Then you factor it. So have x, 3, 1. Middle term -4, so become negative. Okay, so x equal to 3 and 1. 3 or 1. Okay, this is minus, yes. Okay, so but every time, most of time, logarithm, you have to check same thing in the equation. You have to check may or may not both can work, like x equal to 3 and 1. Okay, sometimes only one value can work on, sometimes can work both at all, sometimes can work all of them. So then you have to check, say x equal to 3 is work and also 1 is work or not, right? Actually, this one you can check also, right? So then say if x equal to 3, then now we're gonna check or say this the equation correct or not correct. So you replace x in there. Replace x in the equation. So become log x replace here become 3 times 4 become 12, right? Minus 3. And base is this x is equal to 3, equal to 2. So what we have, 3 minus, we left 9, right? Base 3, so equal to 2. Then you can see right now we check, right? So do again. Put this one, right? Move this one up. Move 3 is a base, right? Put to this side. So become 3 power 2. This one move already, right? So we left this side 9. So then this is 3 power 2 equal to 3 power 2. Then it's correct. So x equal to 3 is work. Okay, it's work. Now we can check x equal to, I have to check x equal to 1 is work or not, right? Now we're gonna check this one. So I light that up here, okay? If x equal to 1, see how it's work or not. So replace it. X equal to 1 times 4 is a 4, right? Minus 3. And base is 1 equal to 2. Aha, now you see this? What you can observe? Base here, 1. But the question or the definition already say shouldn't be 1. So then this one is undefined right away. Okay, because the base shouldn't be 1. Okay. At the same time, in this case, right, if you simplify, log 1 base 1 equal to 2 or not? No. So log 1 base 1 is undefined. Okay. So this one we can prove log 1 base 1 is undefined or no solution. You see at this one, I want to prove this one right away. Okay. So for example, if I have 1 equal to 1 power 1, correct? If I like this one more time. For example, I want to prove why this one doesn't work. Log 1 base 1. Okay. So if I have 1 equal to 1 power 1, right? A1. Then I want to convert this exponent form, right? Then I want to convert to logarithm form. So I have log this one, right? This one. But this one is, I like this one. This one is the base, right? So I write down here. And then the number 1 here, put in, take place of number 1, correct? So become 1. Okay, this one is sim. You can use calculator also, okay? Now you see this one, next one, right? If I say 1 equal to, maybe I say 3 power, so I mean 1 power 3, sorry. If I give this one, say this one 1, right? 1 equal to 1, maybe say power 4, right? So then this is the base, okay? So I take log 1 and write down 1, right? But this is a base. I like the same color so you can see clearly. This is a base. So base I write down here, okay? And then 4 take place of 1 here, right? So this equal to 4. Now you see these two. Now you take a look at this one. Log 1 base 1 equal to 1. And also log 1 base 1 equal to 4. So they are conflict, right? So we can say this one undefined right away. Okay. Even though you see 1 here is a position of y, right? Which is greater than 0 is correct. But this one base 1 is conflict with the definition. Okay. So this one undefined. So just say if you have any log 1 base 1, you always say no solution or undefined. But if we have log 2 base 2, this one equal to 1. Log 3 base 3 equal to 1, except this one only, except this one. Okay, log 4 base 4 equal to 1. Log 5 base 5 equal to 1. You can use a calculator. I forgot to tell you how to check it. Now you see this one, if question A, come back to question A, we want to check this one is work or not. So we get x equal to 9, right? So you replace in the question. So I have log 9 base 3 equal to 2. Okay, now from this one, how you do? Use the definition of logarithm again, change to exponent, right? So 3 move to this side, put 2 up. So become 3 power 2. This one move already, so you left 9. So this one equal 9. So this one work. Everyone see that? And this one also same thing, eh? Same thing you can check also. Okay. Now we go next example though. Now this one. Oh, this one we talk about now on this ABC can say it's a formula you can keep in mind right now. This is a formula. Like I just finished tell you, say if you have log 2 base 2 equal to 1, right? Log 3 base 3 equal to 1. No matter this one same, always equal to 1. Except log 1 base 1 undivided. This one no solution. But the rest is okay. Okay. Log 100 base 100 is equal to 1. Okay, that's a 1. This is a 1 formula. But then we need to prove this one. How to prove this one? Okay, now we're going to prove the formula now. Or ABC here is a formula. Okay, one keep in mind. Gonna use a lot. Now we want to prove it. Prove the formula. How we gonna prove this one? I can do this way, right? The proof. Now we prove this one, right? So if I have a equal to a power 1, correct? So then I can take log, right? Log a. And this a mean this a, okay? This a mean this a. And then now this a is the base of exponent. So I like become base of the log here. Equal. And the one here, you take place of this a, right? So one gonna be here. So now we prove finish. Okay, use the definition of log to prove. Now question B. B, how to prove log 1 base a equal to 0. Okay, so we can use the idea say because 1 equal to a power 0, correct? If I like this one, 1 equal, because a can be any real number, power 0 equal to 1. This one is true, right? A1 no, right? So then again, I use take log, use the definition. This is the base, right? So I take log 1 and like base become base of the log here, and 0 take place a 0. Okay, so finish. I got it. Same, right? Same. Now I can prove question C. We gonna start the proof. We start the proof. See, then now you see this one log x base a, this one log x base a, same, right? So I will let m equal to log x base a. Okay. After this one, I will use the formula again from the logarithms. Base, right? Base of the log, move to this side. Okay, so a gonna be here and move m up, become index. Remember, we worked several equation already. One, this one move already, so you left x on the bottom. Let x, right? Okay, after this one, you see, because x power r here, so I need x power r. This is x power 1, so I need the x power r like this one, right? Like here, like this one. So I will power both sides with r. Okay, so then this one I will have x power r and a power m r, a power m r. Okay, so after this one, what I can do? You see this, because the question, I mean the formula base is a, right? Base is a. So in this line, you can see both of them is like exponent form, right? So it can be either one is a base. A is a base. X also is a base. Then I want base a, so I will take this a is a base. Okay, and this take the whole thing one number. So in this case, I take log x power r. And then this is a base. Okay, I want to take this a is a base. So I move a to be base of the log, right? Remember? Then mr take place of a, right? Mr take place of a. So mr here. After this, you see, right now we replace m equal to log x base a, right? M equal to log x base a here. So I write down log x base a times r, right? Equal to right hand side log x power r base a. So you see this one is same already, correct? So this time r, can I lightly write it down, become r log x base a equal to log x log x power r base a. So you see this one same enough. Then we prove already, correct? We already prove it, right? Because you see this same, right? Log x power r base a means this one exact same. Equal to r log x base a, this is this side. So now this one proof. Okay. So then A, B, C, please keep in mind this is a form one formula. And also I have some formula you need to keep in mind. So I add so far right now, I summarize from formula for you. The property of logarithms. Okay, so far we learned today, right? What we have is what? Like this one, right? A, we have log A base A equal to 1. And log 1 base A equal to 0. Okay. And this one is the index form. So you have log x power r base A will equal to r log x base A. Then we have another one, a power r base A, right? Equal to r. Okay. Why? You can see r can move to the front according this formula, right? So become r log a base A equal to r, because log a base A equal to 1, right? This one log a base A equal to 1. So that's why 1 times r equal to r. And this another one is, if I have a log r base A, this equal to r. Practice question check in GC. Okay, bye bye. See you next class, next time. Bye.